There are some truly great stories about drug discovery, the kind that inspire children to become scientists. Stories like Alex Fleming's accidental penicillin discovery, or Louis Pasteur's leap of faith to save a young boy's life with his rabies vaccine. Maybe lesser known but equally transformative is the story of Brian Kobilka imaging a G protein coupled receptors. This is a story of ingenuity and resilience that beat the odds to become the perfect example of research success story. G protein coupled receptors are surface receptors with one end outside the cell wall and the other inside. How signal bypassed the cell wall to connect the inner cell to the outside world was a mystery until the first surface receptor was discovered by Robert Lefkowitz in the 1960s. GPCR receptors are a family of surface receptors that change shape after connecting with hormone or neurotransmitter outside the cell wall, bind to and activate G protein molecule within the cell to trigger a cascading metabolic effect that changes the cell's behavior. The physiological responses that start with GPCR receptors range anywhere from sensing an odor to the adrenaline rush of fight or flight. Brian Kobilka joined Lefkowitz and his team in 1980 to sequence the gene responsible for the adrenaline beta receptor. Kobilka led the way to isolating the gene, and their gene sequence led to remarkable development. The adrenergic receptor looks and functions very similar to another receptor that's not in the endocrine system, the rhodopsin receptors in the retina of our eyes. Those two, as well as others, all have the same 7 helices and all bind to G protein in the cell. This leads to the discovery of the GPCR family, a subtype of surface receptors that look and behave the same, even though they have different functions. This knowledge has helped researchers better understand how receptors and cells work and how to regulate them on a molecular level. This was not the end of Brian Kobilka's GPCR journey. After that first eureka moment, he took on an even more challenging task, creating an image of the receptor. Imaging a water-soluble protein is already a complicated task, and GPCR are in a fatty acid, making the job even more difficult. On top of that, the spiraling in and out of the cells make it really hard for the GPCR to sit still in a crystalline state. And as many of us know, basic research doesn't usually get as much attention as applied research. And his goal was thought to be impossible by many in the scientific community. But with a small team of dedicated researchers, with 20 years of hard work, and with what he called irrational optimism. 2011 marks the year Kobilka overcame the limited funding and discredit from his peers. He captured a 3D image of a receptor transferring a signal from a hormone to a G protein in the cell. While he continued his receptor research, scientists today continue to take benefits from his work. Understanding how cells communicate has been incredibly beneficial for pharmaceutical research. Considering nearly half of medication today works through GPCR receptors, the importance of this discovery for drug screening and drug discovery is fundamental, unquestionable. If you enjoyed this video, please subscribe to learn about other inspiring scientific work, and click the link in the description to learn more about Brian Kobilka, Robert Lefkowitz, and their Nobel Prize winning the GPCR achievement.
HORIBA.